Okay, so for this question, they're saying that it's 2,310 miles that it flew with the wind in 3.5 hours, and then 1,820 miles that it flew against the wind. So for these questions, we're going to let x be the plane speed in still air, and we will let y be the wind speed. So if you think about the idea of the plane flying with the wind and against the wind, when you are going with the wind, you will have the initial airspeed, and then in addition to that, you will have the wind speed, because now the wind will be helping the plane, it will be pushing the plane further along. Now, this needs to be equal to the speed that we know coming from the distance formula, that distance over time is equal to rate. So what you'll do is you will take the 2,310 miles and divide that by 3.5, and that will give you the rate of the plane with the wind. So again, you'll just take the 2,310 divided by 3.5, and that gives you 660. And you'll notice here, like this 2,300 number, that's in miles, the 3.5 is hours. So this is telling you that the plane speed with the wind is 660 miles per hour. So on the right-hand side here, when you're talking about the speed with the wind, you will have 660 for the speed with the wind. Now, to get your speed against the wind, in that case, you're going to have the plane's airspeed, so that engine speed that's being put into the plane, but then now the wind is going to be hurting that speed. So we need to subtract away the wind speed. And then that's going to equal what we know the speed to be based off of this given information. So you'll take the 1,820 divided by the 3.5, and that will give you that it's 520 miles per hour against the wind. And so that becomes your linear system. The x plus y equals 660, and then the x minus y equals 520. And you'll notice here, this linear system is really set up very nicely for elimination because you do have a plus y and a minus y. So the easiest thing to do is going to be to use your elimination method. Remember, for the elimination method, we need those opposite coefficients, and we do have those, the plus 1 and the minus 1. So we can immediately just add the two equations together. So 1x plus 1x is going to give you a 2x. The y's are going to be eliminated, crossed out. And then adding the 660 plus the 520, that gives us 1180. And then to solve for x, we just divide both sides by 2. So take 1180 divided by 2. And that gives us x is equal to 590. So that x represents the speed with the wind. And then we need to find the speed against the wind. So remember, what we did here is we added the two equations together. We solved. And now the last step is to substitute in to find that other unknown. So to substitute in, you can plug in either equation, it doesn't matter. So I might pick the first equation, that x plus y equals 660, and plug in that x is 590 plus y equals 660. And then just subtract the 590 from both sides. So again, all you're going to do is take the 660 minus the 590, and that gives you 70 for the wind speed. So your engine speed, or plane in still air speed, is the 790, or the 590, excuse me, that would be your still air speed. And then your wind speed is the 70.